Hello everyone, my name is James Pruitt. This is my 10th lecture on generating functions, and we're going to pick up where we left off last time. We were working on the solution to this equation here. We have this sequence A that's equal to x times the multiplicative inverse of 1 minus x squared. And we were working on computing the multiplicative inverse of 1 minus x squared. Times x, and we could do that the way that we've been doing it, by getting rid of the x and then getting rid of the next highest power and then getting rid of the, like we did previously. But last week we discovered a method of being able to factor this and do a partial fraction expansion and get it in the form of a sequence that we've already seen before. Such as we're trying to get it into a form like 1 minus cx, and that way we know the multiplicative inverse of 1 minus cx, so we don't have to do that method in the proof, that in the theorem, that method I described for the proof of the theorem, that a sequence that has a non-zero constant term has a multiplicative inverse. So that's what we started off doing. So the first step we had to do was, because we want to do a partial fraction expansion, is factor this denominator, and we're just using the basic quadratic formula. And we computed, we got it down, we computed the roots of this guy right here, and it turned out to be this times that. And this right here, we said, was a famous a number called the golden ratio. So in the golden ratio is called phi. That's the standard name they give to that, and it's an approximately equal to square root of 5 is an irrational number, so this is an irrational number, but it's approximately equal to 1.618. So we also said that 1 minus phi is 1 minus the square root of 5 over 2. So we have these 1 minus phi here and phi here. So we come down, we got that. Now we're down right here. Now we're ready to do the, since we have the denominator factored, we're ready to do the partial fraction expansion. And the method that I use is called Heaviside cover-up method. I think this is Oliver Heaviside's figured this out. So what we do is we divide up the fraction with this unknown a over x plus phi plus this unknown b over x plus 1 minus phi. Excuse me. And how do you do this Heaviside cover-up method? Well, you multiply, to get the a value, you multiply by x plus phi. So they cancel that out of the denominator, and you got an x plus phi here, and then the x plus phi cancels that out, and so you plug into x. Once you've done this multiplication of both sides by x plus phi, you substitute x for negative phi, and so there's still, right on this term, there's still an x plus phi, so negative x plus phi is 0, so they knock this term out, so you're just left with a, and then you substitute in x negative phi, and this is gone, this term is gone, so that comes out to be a is equal to phi over 1 minus 2 phi. And then we show that 1 minus 2 phi is equal to negative square root of 5. So that gave us negative a is equal to negative phi over the square root of 5. And then we did the same process, and we figured out that b is equal to 1 minus phi over the square root of 5. And then we come back down here and we substituted that in, and that's what we got. And then what we wanted to do, we're trying to get it into the form, like we said, we know this 1 minus cx, that's a form we know. We know the multiplicative inverse of 1 minus cx, and that's 1 plus cx plus c squared x squared plus dot dot dot. So we want to get these guys in that form 1 minus cx. So what we have to do is distribute out on this term the phi, and distribute out on this time 1 minus phi. So we did that, so that's x over phi plus 1. The phi's cancel, the 1 minus phi cancels when we distribute out that 1 minus phi, and you get x over 1 minus phi plus 1. Okay, and we come on down here, and so that's where we're at. So now we want to turn it, we're still aiming for 1 minus cx. That's what we're aiming for. So we're trying to get it in that form. And so we have a little bit of manipulation to go from here to here. We just flipped it around, and then we subtract a minus minus. That's really a plus. So that's 1 over 1 minus phi x, and this is minus minus 1 over phi x. So that's where we left off. So here we go. Let's finish this up. Okay, so we want to look at these terms. So we're going to look at this term, negative 1 over 1 minus phi, and see what that's equal to. So that's going to give us negative 1 over 1 minus 1 plus the square root of 5 over 2, and that's equal to, we go ahead and multiply out the 2's, right? We'll multiply top and bottom by 2, so that's going to give us negative 2 over 2 minus 1, and we bring in that negative, and that's minus the square root of 5. So that's equal to minus 2 over 1 minus the square root of 5. Okay, so that's going to bring that down here, and that's equal to, so we want to get, we'll do this standard technique of you do what complex, or I do what complex numbers to get the complex numbers out of the denominator, or to get the square root out of the denominator. So we got 1 minus the square root of 5, and then I multiply top and bottom by 1 plus the square root of 5 over 1 plus the square root of 5, and then and that's equal to negative 2 over 1 plus the square root of 5 over, and that's going to be 1, the negative 5 times 1 and the 5 times 1, they cancel out, so negative square root of 5 times the square root of 5 is negative square root of 5, and that's equal to, actually let's, okay, and that's equal to negative 2 times the 1 plus the square root of 5 over negative 4, but that cancels that out with that's 2, so that's just phi. So what did we prove? We proved that negative 1 over 1 minus phi is equal to phi. Now for this other term here, this other term, this negative 1 over phi, so that we got that. This term right here is just phi, and this term right here, we're going to see what that might turn out to be. So you got negative 1 over phi. We'll keep this. This is important. Negative 1 over negative 1 over phi is negative 1 over 1 plus the square root of 5 over 2, and I'm going to multiply top and bottom, and then I'm going to flip that 2 back up there. So that's going to equal to negative 2 times 1 minus the square root of 5. I'm going to multiply this on top and bottom. So that's 1 plus the square root of 5 times 1 minus the square root of 5. And that's going to give us negative 2 times 1 minus the square root of 5 over, again, this is 1, the square root of 5 times 1 and the minus square root of 5 times 1 cancel out, and that's going to give us square root of 5 times negative square root of 5 is negative 5, plus 1 is negative 4, so that's going to be negative 4. This cancels out, and that's going to leave 2, so that's equal to 1 minus phi. So there we go. So negative 1 over phi is equal to 1 minus phi. So we come back up here and we see this. Let's see, man, we got to go way up here. Let's see where I'm at. Okay, right here. So this is the equation. We're going to substitute that result in. So we're coming back down here. So we're going to say that's going to be A is equal to 1 over the square root of 5 times 1 over 1 minus phi x minus 1 over 1 minus phi x. And let me double check that real quick. Okay, so that's here. So that's 1 minus, that negative 1 over phi is 1 minus phi, and negative 1 over 1 minus phi is just phi. So we got that. That checks out right. So this is the equation we're looking for. This is the equation that gets us. We have this form. These denominators are in this form, 1 minus cx. So they're in the form 1 over 1 minus cx, and we know what that is. Let me clean that up better. Let's see. So we have 1 over 1 minus cx is equal to 1 plus cx plus c squared x squared plus dot dot dot. Okay, so now let's just finish this up. A is equal to 1 over the square root of 5 times 1 plus phi x plus phi squared x plus dot dot dot, and we're going to minus 1 plus 1 minus phi x plus 1 minus phi squared x squared plus dot dot dot. So now we can now we have our a. This is our generating function, and so we're pretty much done here. So what we're going to do is just, I'm going to, since it's getting a little complicated, that's sort of ugly up there. My writing skills are getting bad. Let's see. So it's getting sort of complicated. I'm just going to write it as let this is the generating function of the sequence a sub n, where a sub n is equal to phi to the n minus 1 minus phi to the n over the square root of 5, where phi is equal to 1 plus the square root of 5 over 2. And that is the sequence. This is called Fibonacci. That's the sequence that satisfies the recursion an equals an minus 1 plus an minus 2, where a naught's equal to 0 and a1 is equal to 1. So that's, we transformed this recurrence relationship into a algebraic. This is a recurrence relationship involving complex numbers, or an equation involving complex numbers. We transformed that into an equation involving sequences. We manipulated that algebraically. We factored it, and we got it into a form that we've seen before, and we use that to compute a sub n. So this is the completed form. This is the what's called a closed form for this sequence, and that's what we wanted to do. So we're done with the Fibonacci sequence. Okay, thanks a lot. Have a good day.